Can you see the screen? Can you see the screen?
Yes, sir.
Yes, sir.
Okay, this is a course in operating system, and I think Animesh, he has already started the course, and he has done with the introductory classes on what our operating system is and what are the different modules of an operating system. So this class I'll be starting with the tutorial. In fact, it is outline of the process management. And so before I start, so what is OS? I mean, in a very short definition, what is OS? Hello, just quickly tell me the definition of the OS.
So basically a system that can divide tasks, assign priorities, and manage all the other softwares in a computer system.
Well, yeah. So this is the operating system is a system software,
Yes,
and it actually manages all the different system resources, and that is the CPU, the memory, the files. And so when you talk about software means, so the any software is generally organized in some of in form of a file. So the files, and finally the IO devices. So in an operating system course, the entire course is divided into 4 broad modules. One is the CPU management, memory management, file management, and IO management. Okay, and definitely the main focus will be in learning the CPU management, memory management, and also to some extent file management. But this IO management we may not be able to cover in more details because of the shortage of time and all. So let us see. So CPU, memory, and file management, these will be taught, and mostly myself and Animesh will complete this CPU management, and Animesh also will do the file management, and MS ma'am, she will cover this memory management. So now this when you talk about a process, so do you know what a process is? What is a process?
Sir, program and execution state is called
Program in execution. So it is like say any boy who has taken an admission. So once he takes the admission, he becomes a student, right? So once say you before you cracked a JE mains, and then you got a rank and everything was fine, but once you got enrolled in this particular institute, you got a studentship, right? So now you become a student. So student is probably a manifestation of that particular candidate or that particular boy who joined the institute. Now once he becomes a student, now he starts manifesting his presence through different means, right? So what is the first thing once a student enrolls is done? What is the first thing that is done?
Sir, enrollment number, sir.
Yes, what so during the enrollment process or during the admission process, what you are given with?
Sir,
How a
Admission
student?
number.
Hello?
Admission number.
Some number, right? So what is that number called? So this is sometimes called the registration number, or maybe the roll number, something like this, right? So it is required to uniquely identify a student from others. What else do you expect once you join? Now tell me quickly, these are trivial things. So apart from getting some numbers which are unique for each and every student that is who are active in that particular batch, or who are a student of that particular batch, what else you would expect to manifest your presence?
allocation of a particular section.
Yes, allocation of a section. But even before that, I mean, even before the classes start, what do you expect? You join the institute, you got a roll number. Now You're not going to stay in the oval ground, right? What do you want?
Hostel allowed.
room.
Hostel accommodation, right? So this is important. So now once a person or a boy who joined starts manifesting, so the first thing is he gets a unique number, and apart from other details, we can say that he gets a hostel accommodation, right? And then definitely it comes that okay, you are he's belongs to a particular department, so he gets a department tag with it, and then there are other like, so once he joins different courses, so these are logical identities, so a student can join multiple courses like that, and he will have different activities and all this, and every time he performs something, say he wants to join some club or say attend classes, so he will be using some of the resource in the institute, right? So same holds in case of process also. So in a process, say if we have a program means executable code, and so then the program, as we say, once it starts running, we call it as a process. So the equivalence is this program is the boy and the process is the student, right? So student is the active manifestation of the boy who has got enrollment, and as the boy gets a roll number or registration number, the student will get the student will get that. The process also will get some unique identifier through which it can be identified. This is called the process ID, right? Have you heard of it? Process ID?
Yes, sir.
So the thing is, and in a computing system, if we come in terms of the computing system, how many processes do you think we can run? Can we run just one process at a time, or we can run multiple processes? And can we run infinitely large number of processes?
So in a single CPU, a single process can run at a time.
In a single CPU?
So in a single CPU, only a single process can run.
See, the point is in a typical student case also. So students, how many gets enrolled? Say maybe 400 students gets enrolled in a batch, right? Now, when you say CPU, so what can be the equivalence of CPU in your case, in a student's case? What can be the equivalence of CPU? Maybe say attending classes, right? So CPU is something like a classroom. So if you think of a classroom, how many classrooms we have got in our department? Maybe two or three class, or say two classrooms, and how many students we have got? Say maybe or maybe how many say years we have got? Say 4 years. I mean, say CSC second year, third year, and fourth year. Now the thing is, because you have got two rooms, you cannot have classes of second year, third year, fourth year simultaneously, right? So what do you do? How do you manage then? So you have a routine. So maybe that at a particular point of time, third year and the final year classes are going on, and second year where they are staying, during when they don't have a class,
In the hostel.
in a hostel. So they are staying in a hostel, and these two groups, they are having classes in the classrooms, right? Lecture halls. Now once this third semester or third year class is over, might be that the fourth year still is continuing, but the second year now gets that same classroom and they are having the classes. So similar things happens here. So although you see, so you have right away pointed out that if there is a single CPU, there can be just one process. But is that the case? So when you are running in your machines, say you are running a song in the background, you are running your internet for, and you are downloading something. At the same time, you are writing a code, and also might be that you are running some other applications in the background which you cannot see. So, and what do you think? How many CPUs you have in your laptop? How many physical CPUs, processing units you have got? Any idea? Do you have just one CPU?
Yes, sir.
Are you sure you have just one CPU always?
Not always.
So these
Sometimes.
days we have got, say maybe dual core or dual CPU, two CPUs, or maybe four CPUs like that. And sometimes we may have got one CPU also. But these days, whenever you buy a laptop, or even you buy say smartphones, they are having multiple processing units. Say CPU, physical CPUs, right? So the thing is, but if you have got two CPUs, do you think now only two process will be there?
No, sir.
So generally we run several hundreds of process, or at least 10, 20, 100 number of processes there. So now what is a process? So process is a student. So again, try to think of the analogy that you are a student. And now when I say, so probably what you mean to say is only one process can run if you have got one CPU. Is that what you mean? If you have got one physical CPU, then how many processes you can run?
So one.
So
So
you
one.
have got multiple. Say you have got multiple processes: process 1, process 2, process 3, process 4, and where they are staying, where they are stored.
So in the
Even
ready
if they are
queue.
not, where they are stored.
So in
The waiting state or ready state?
Now where they are stored, where they are waiting now. Even if they are waiting,
Main
where they are.
memory. So main memory RAM.
So it is a hard disk. So definitely the entire code, everything, it is in the hard disk. But if it is the RAM, maybe that portions of the processes will be accommodated here in the RAM, right? So some portion of this process is here, some portion of this process is here, right? And so maybe these processes, portions of the processes is in the RAM, because if you have got say 200 processes, and there may be some processes or some files they are so big that uh, occupies or requires maybe more than 1 GB or 2 GB, but your RAM may not be, you may have a 2 GB RAM, but your process is a single process maybe of 4 GB. Okay. So the thing is, these processes are generally residing in the hard disk, and as and when required, they are swapped, or their portions are brought into the RAM, and there are small locations, or a portion of the RAM is dedicated to each of these processes for their running. The details you will learn in the memory management. So once these are done, now there is a single CPU. So if there is a single CPU, and even if some portions of process 1, some portion of process 2 or process 3 is there, so maybe process 2 is currently getting executed here, right? And process 2 and process 1, they are waiting. Now, do you expect that process 2, once it starts, it will continue forever? And once it is complete, then only P2 and P3 will run, P1 will run?
No, sir.
No,
Because
sir.
that will be typical monopolization. So here in this case, if the second year class has started, and if they say that, okay, let us complete the entire course, and then or maybe then the fourth year will start, or the third year will start. So that is quite absurd, right? So if you have got limited resource, and then CPU is one kind of resource, it's a very important resource, because the programs, once it is converted into exe files, until unless you execute, you get nothing out of it, right? It's CPU, but the CPU, the number of CPUs in a machine or in a computing system is far less than that of the number of processes which can be active in the system. Okay, so active means so here active means it is not running, may or may not be running. So active process means it may be running, or it may be sleeping means, or maybe there may be other terms like waiting or whatever you say. So it is waiting for the CPU to be allotted to it. So when the students are waiting in the hostels, so they are, they are doing their own activities. Whenever their turn comes, they knows that, okay, this is our turn, and we'll get hold of the CPU, like that. So the processes, once you start a process from the so these days, using the GUI, we can click on our icon and we can initiate a process, we can trigger a process from the shell, or from the command line we can execute some exe file so that a process is started. So in that form, multiple processes can run, and multiple processes can coexist in the system, can be active in the system, but only one or two or few of them will be in the running state. That depends on how many CPUs are there, right? And who takes care of deciding that which particular process among the active processes will be getting the CPU, and for how long?
Term scheduler, sir.
Hmm?
So short-term scheduler, sir.
So these are scheduler, short-term scheduler. Good. So the scheduler, because in our case, in your in your classroom case, we have a routine. So that is fixed. That is fixed for the entire semester. It is fixed. There is no change. But we cannot have a routine kind of thing in while assigning or allocating the CPU to the processes, because of the simple thing. Why it is not possible? Because you don't know the demand, right? A process 1, process 2, process 3, there are multiple processes, but the CPU, but the system, the operating system, because operating system is the resource manager, like the mess manager or the hostel manager. Operating system is the resource manager. It manages the CPU, it manages the RAM, it manages the hard disk, everything it manages. So the operating system knows that. So prior to the execution, the operating system does not know how much time this process 2, process 1, process 3 will be requiring the CPU. But definitely it cannot assign the CPU to a process so that the process can monopolize and stop others to execute. So that is one problem. So that's why a small module of the operating system, or maybe the process management module, it runs some algorithm which is called the scheduler. So what is the task of the scheduler? It decides which of these active processes which are waiting to get the CPU will be assigned the CPU, right? And then after it gets assigned, how long it can continue? Will it continue for a few nanoseconds, or it will continue for milliseconds, or whatever? Or even though or maybe the process voluntarily releases, says that okay, I am done with the CPU. Now I am going for taking an keyboard input. Okay, again I'll come back and try to grab the CPU, like that. So the scheduler is there. So what I mean to say is, processes are a key, say you would say the entity which operating system need to deal with, because processes are the execution units. And in fact, it is not a true statement, because the threads are the unit of execution. Let us not get into those details. So it is important to know. So that's why we have started with this process management. And I think Animesh has also started this. So process management deals with whenever a program, means a exe code or executable code, is whenever we execute it, or we click a button to create a process is created. So once it is created, how this allocation of resources takes place. That means something similar to the hostel allocation. Then you have got some allocation in the SAC. You have got some allocation in the in your canteen and all this. In the department also might be that there will be some seat meant for you where you can get your sessionals done and all this. So this entire allocation is done. So the first thing is done is the system gives you a unique ID. So every process needs to have a unique ID, like the roll number or registration number of a student. At the same time, it will have some space or some entries in the data structure, because there are so many processes and the operating system need to maintain a suitable data structure to keep track of all this, right? And the details of the data structure will read in terms of the Linux operating system. So once there is a data structure, it will have an entry in the data structure. So it will have, say, maybe one node will be created for it. The details of it will be stored, and that node will be linked to some other nodes and all this. So all these things will be done. And once this is done, now you know that the process is ready. The process is ready for execution. Okay. Now, if it is ready to get the CPU, it will be assigned by the scheduler, the CPU. And so during its lifetime, like during the lifetime of a student, during your 4 years studentship, sometimes you can go for a vacation, vacation break. You can attend classes, you can go for exams, sit for exams, you can go for for some other activities like that. So in the similar way, a process also goes through different types of phases, or you can say different states. One is definitely the running state, when a process is getting executed by the CPU. One is the suspended state. Okay, suspended means or maybe it is in a waiting state, ready to run state. So all these details, what are the exact states, we'll discuss about it. So it will actually run to different states, and there's a nice state transition diagram. So from one state, from the running state, you can go to the ready state and coming back and all this. So there are a few very defined states that is in a particular operating system. In Linux, we'll find that there are say 8-9 states, and what is the event that triggers a change from one state to the other. So that also is precisely defined by the operating system designers or who wrote the operating system code. So here in today's class, I'll try to talk about, so the definition of process is already done, the shell command. So how can we see the presence of processes in the system? So that we'll see. And how, if we create more processes, how can we see that, okay, in that list we find that there are more entries there, right? So if a new student joins, in the enrollment list, we'll find that there is an entry corresponding to each and every student, and what details the operating system maintains corresponding to a process, that also we can see. So uh, this is process status, and then we'll see the state transition diagram, the context of a process data structures, and there are different system calls through which we can manipulate, we can create, we can send some kind of signals to it. So there are many uh, system calls to which we can control and manipulate processes. And what is a system call? I think these are part of the introductory class. So a system call is, you see, when you talk about the OS is, so this is the core of the OS, operating system, and generally the core of the operating system is called the kernel. So it is the essence of the OS is all included there. And because so in this kernel, the OS takes, or it actually uh, stores all the policies that is meant for. So what is the scheduling policy? What is the policy that how many process should be in the RAM at a time? What is the policy that how much of share of the RAM a process will get at most? Because you have to accommodate many of them. Then if a process is getting not getting scheduled for long, then what sort of policy will be taken on all this? And sometimes if you find that a process is created and no more space is there in the RAM to allocate some space, so what should be done? So all these policies related to the management of the different modules, or the different components of this software system is all included here. But as a user, it becomes very difficult for the user to know all the details and seek. So the user is not supposed to do all the internal details of how the OS is functioning. Rather, the user or a programmer, as a programmer, you would be interested to make a request to the operating system kernel, and the operating system kernel will provide, once you have requested, it will provide you with the answer. Or if you ask it to do something on its behalf, it will do that, and it will say that okay, it is done, or it is not done. Okay. So typically a user, I mean any user, application user, like when I log on to the system, I am a user, and might be that if it is a server kind of system, there are multiple users who has logged on. So a user, whenever we try to work, what we do, how we uh, how we interact with the operating system.
Sorry, interrupts.
Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Sorry. Again, there was a, so now can you hear me?
Yes, sir.
Yes, sir.
Okay. So did you get this or It got snapped even before this. Hello?
Sir, the question was snapped.
Yeah. So the question is, so this is the operating system kernel, right? So it includes all the policies, the functionalities that the OS performs while it manages the different system resources. Now, as a user, there is a user 1, there is a user 2. So we are the users which has logged on into the system. Now, how the user is going to use operating system, so how it is done, how we generally take help of the operating system in you know running our applications and all this, how we do this, what are the two ways to do this, how a user interacts with the operating system.
Sir, the command line and the user interface, GUI.
Okay, so it is the either the commands, the UI, because these days the Windows is a GUI based system, so you don't even type commands. Many of you don't know the commands that is available, so that you can use in the through the command line interpreter. So there is a UI, user interface. If you click in some buttons, it will trigger some codes, and I mean maybe in the background it will trigger some commands, and that will that command will be forwarded to the operating system. It will do it uh, the required task for you. What is the other way of doing things? If you are a hardcore programmer, then probably instead of writing just executing predefined commands or using some UI, what do you prefer? How a programmer would like to interact with the operating system kernel?
Make a batch file.
Terminal command line. Command prompts.
So system calls.
So a programmer will prefer to interact with the operating system kernel through system calls, right? So what are system calls? Can you say? I mean, what will be the system calls? So system call is just like if you, because you are a programmer, so what you want is if you know a function, so you can just call the function, right? So system calls are, it appears to be like functions. It's like function calls, but they are not normal functions. So the thing is, if you would like to say, for example, if you would like to allocate or get some space from the RAM while you are running the program, so what do? If we would like to have some more space required for storing our data while I execute a program, so how as a programmer I would request the OS to get it done for me.
So new operator.
It
So
may be
dynamic
new,
allocation.
calloc, whatever, right?
Yes.
So this new malloc, calloc, so do you think that they are system calls? Because you see through this malloc or new, you are trying to seek some more space in the system resource, that is the RAM, right? So if you do so, so you cannot, so you just can make a request to the operating.
Sorry, you're frozen again, sir.
Hello?
Yes, sir. Now audible.
Yes, sir.
No.
Actually, I have tethered from my mobile phone. Whenever a call comes, it drops. So the thing is, as a programmer, so I may call new or I may call malloc, right? So is it a system call? Malloc or new? Is it a system call?
Yes, sir.
Do you think that it is a system call, directly a system call? How many of you think that it is not a system?
So it is not a system call. It is in a library function, and that library function calls the system.
See, the problem is now the system calls are having too much of flexibility, and they are designed in such a way that you might have to pass certain arguments which will be directly required by the operating system kernel. So if you look into the system call like this, so it might look like memory, alloc, and then there may be 3-4 arguments. Okay, and these arguments, there may be some arguments which is much related to the low level details and all. So what happens, instead of having these system calls called directly by a programmer, generally what we do, these system calls are wrapped or encapsulated in a form and some functions are created. Okay, so these functions in turn actually, so you basically call a function and this function in turn call the actual system call which is going to do the memory allocation. Are you getting the point? So
Yes.
there is indeed a system call which can allocate space for you, but that raw system call sometimes is not easy to use for a normal programmer, and it becomes very difficult to recall those parameters, and some parameters will not be able to find out what it means and all this. So sometimes what happens, and in most of the cases, there are functions which are designed so that if you call those functions in turn call the system call. So do you know what is called this process of uh, wrapping up the actual system call uh, within a function?
Encapsulation, sir.
What is this? These are wrapper functions. So because of these wrappers, the programmers, so their life is now pretty, so they can enjoy their life because they don't, as a programmer, you don't need to recall all those details. Sometimes some system calls might be very simple to understand and the parameters also easy to say interpret, but there may be some system calls which are not that easy. So but some simplified version of it is created. So there is another kind of interface which is called wrapper function. So the wrapper function, in true sense, it wraps the uh, integrate details of the system calls, and when we work, in most of the cases we deal with these wrapper functions, but sometimes we say that okay, those wrapper functions are the system calls. Okay, so we'll be talking about some details of some of the system calls, and we'll see that what is the underlying algorithm that a particular system call executes. So like there are system calls for, wait, exit. So these three system calls are very important, and we'll have the details of this, the algorithm for this for, exit, and wait. And this for actually, if as a program, if you call for, so you will be able to create a new process, right? So by calling for, you can create a new process. What other ways you can create a new process? By uh, clicking a button which actually triggers the exe function, executable, or by directly typing exe file name, or maybe a.out /a.out. So that way you can trigger new processes, right? But if you call, so I wrote a process, say I wrote a function like this, sorry, a code like this, and if I call for, so when I wrote this program, and if I run the program, so this program, so I myself become a process, but within that process, if I execute the statement or this function for, that means me as a process creates another process. Okay, so if I write a process, and within that process, if I make a call to this fork, fork, that means once I execute my original process, say if this is a, and if that a has called fork, so a will create another process, say b, right? So in that way, as a programmer, you can create processes, new processes, not only by clicking those Windows buttons, or not only by typing commands, but also by through your programs. So within the program, you can create far more processes, and those processes in turn can create more processes like that. So this is possible, and these functions. So just a minute. So these functions are sorry, these system calls are actually meant for creating a process. This is for exit, means we can terminate a process, and this wait is for synchronizing. We'll get into the details of it. And there are some system calls which are related to process scheduling, as we found that scheduling is an important activity, or important say task that the operating system need to perform. Now you definitely cannot say that you schedule me, but you can tune to a certain extent the scheduling parameters. And there are some system calls which is which is meant for sending signals. Like you know that when you stay in the hostels, and if you think that you are a process, like equivalent to a process in a computing system, so you as a student may may like to send some information, or communicate to some of your other friends, like in your same batch or in your same project group or something like that. So what kind of communication you perform, how you send some signals, how you communicate with each other when you stay in the hostels? What are the different modes? Hello?
So WhatsApp or
The communication modes has changed with time. These days you have your WhatsApp, you sometimes write mails, sometimes you directly make phone calls, you send SMS, like that, right? There are multiple modes. So processes also, because if you have got a set of processes active in the system, so those processes will be interacting. It is obvious that they will be interacting, they will be communicating to each other, and sometimes they may not be interacting. So it might happen that say you as a student from say third year may not have interacted at any point of time to a certain to a particular final year student. So that is also possible. But there is a particular time span where both of you were active in the institute. Okay, so in this case also, if you have got multiple processes in the system, so one process may or may not need to communicate to some other process. So what are the ways of communication? As like we have got WhatsApp, then phones and mails, emails and all this, a process, one very easy way and convenient way to make interaction is sending a signal, right? So signal literally is a signal. So you can have, and whenever we have a class, like a physical class going on, a teacher is the faculty keeps talking, how the students interact. So to draw attention, what do, you just raise your hand. So it's a kind of sending signal. So raising hand means you are trying to send a signal to interrupt the teacher, and you say you would like to talk to him or her regarding your problems, like that. So there are signals, and in case of operating system also, and there are some predefined set of signals. Okay, there's a very finite set of predefined signals, and each signal is meant for a particular a specific communication that a process makes with the other, right? So it can be that this is a process and this is another process, and this process wants to simply terminate this process. Now, whether it is allowed or not, that's a different thing, but a process wants to terminate some other process if it is within its say it is a valid or if it is legal. So whether it is legal or not, we'll see later. So it can send a signal, and on the receipt of the signal, this process will simply terminate itself. Sometimes you see, whenever you are accessing memory, and by some means, if you have made some mistake in assigning the addresses while dealing with pointers and all, and you are trying to access the memory, so what it happens, you are trying to access some portion of the RAM which is not meant for you. So you are trying to jump and access to the RAM, the portions of the RAM which are allocated to other processes, and that is completely illegal. You cannot step in your friend's room without his permission. So that is not possible, right? So in this case, also the same thing happens. And if this happens, then immediately maybe the warden issues a letter to you that you are thrown out of the hostel. So it's some illegal activity. So it's something like that. So if you do here also, so then there is a signal that is issued. So who is the monitoring agency? It is the operating system kernel. It is a operating system memory manager. So the memory manager keeps track each and every memory access that is taking place. And whenever there is an illegal access, it will immediately send a issue a signal to that particular process. Something same as that of the warden issues a signal to the student that you have done something illegal. Okay. So this signal handling is something very important. So there are system calls through which you can issue a signal, and you have to specify which signal you would like to send, and you have to specify whom you want to send, right? So, and on the receipt of it, the receiving process, once it receives a signal, it can say that how I'm going to react. Okay, so sometimes say while taking the class, if you are shouting or if you are keep talking, so what the teacher says that just the teacher shows this signal, means the teacher asks you to stop talking, right? Now on receipt of the signal, you may just ignore it. Okay, let him ask me to stop, let me keep talking. So on receipt of a signal, a process may act on the signal, like take some actions, may simply ignore, or mm, can say that okay, how I am going to react. So all these details will be dealt in this signal handling portion. And there are threads and multi-threading. So this I'll talk later on about this, brief outline of this. So threads, you are all aware of the term threads, right? So it's multi-threaded applications and all, and that you know that multi-threaded applications are fast.
Sir, your net has dropped again.
Sir, we have class right now.
Hello. Hello.
Yes, sir, we have another class right now.
Yes. Okay, so it's already time. So I think we should stop here. So this is I could not continue with the class because of so many interruptions. It was merely an introduction. So maybe I'll take one class in this week, talking about some of the interesting aspects of process, and I can give some assignments. So those who have classes, they can leave immediately. Otherwise, those who don't have a class, I think I have shared some books. I think you have got those files. There are books, that is Maurice Buck. There is a book by Stevens, and there is another book by Mikhail Kerish. So these three books are useful for writing codes and solving the different assignments that I give. So in the next class, I'll be talking about.
Sir, did you mail the books?
Yes, I have posted it in that Microsoft Team files.
Okay, sir.
That you can find out, and the video is also available, I guess. It will be there in that Microsoft Team. So when I'll be able to take the class, I'll let you know. So in this week, I'll take one class that where I'll talk about the PS command. So that is a very interesting command, through which we can see the existence of those processes, and we can create process. I can see that what are the different parameters of the process and all this. So we'll start with that. Okay. If you have any question, specific question, you can ask. Otherwise, yeah, there were a lot of interruptions and it was a delayed start. Anyway, sorry for all the problems. Any question? Hello.
No, sir.
No, sir.
Okay. Okay, so I'll let Abhishek know the next class, when will be the next class. And as usual, Animesh will continue with the class. This week specifically, I have got some assignments in the next 2 days. So maybe I'll be taking a class on Friday, not before that. Okay. Okay, then I'm leaving.
Thank you, sir.
Thank you, sir.
Thank you, sir.